Hello everyone, my name is Senem Velipasalar. I am also a faculty member in the EECS department, and I'm directing the Smart Vision Systems Laboratory. Thank you. So today I will try to give you a brief summary of the several research activities that are going on in our lab. So we are mostly working, So we are mostly working with embedded smart cameras, wireless embedded smart cameras. So a while ago when I was first introducing a course, teaching a course, and I told the students that most of you own a wireless embedded smart camera, I remember them looking at me in disbelief. Because they didn't know at the time that the smartphones that they owned are examples of wireless embedded smart cameras. So most of us in this room now own a wireless embedded smart camera, which is just a camera that's attached to a microprocessor, and it can communicate with surroundings through a wireless radio. So when you work with wireless embedded smart cameras, there are a bunch of challenges. First of all, they are powered by batteries, so they have limited energy resources, and their processing power and memory are limited, and we also have the limited bandwidth problem. Most of the applications that we focus on are implemented on this embedded wireless units. The first application that I would like to talk about is this indoor scene understanding with vision-based smart autonomous UAVs. So here we use a Java plus OpenCV-based platform to perform the processing on the actual UAV, and we detect objects in the scene when UAV is flying in a room, and then we also detect faces in the room. So I will try to play a video now, and it never goes right, so hopefully it's gonna play. So let me tell you what to look for in this video. You are gonna see a UAV flying in the room and a person. So basically UAV is trying to follow the face of the person as the person moves in the room. So as he turns around, the UAV is also turning around and following his face. So there is a camera here, here facing front. So the camera has to point towards the face at all times, and that's what the UAV is doing. We also implemented a fall detection system based on the smartphones that we use, and we try to fuse the accelerometer data that is coming out of the phone with the camera that's already on the phone. And as expected, it's very intuitive. When we fuse these multiple modalities, we get higher precision rates, and our false detection, false alarm rate also decreases, so we get less false alarms. So the camera here is worn around the belt, and then as you move along, it can detect certain activities, so we are trying to, at this point, to detect even more sophisticated activities to conclude the type of things that you are involved during the day. And we also are building a system in which you use your smartphone and then you can detect objects in the scene. So far we have a banana detector and a chair detector, but you know, without loss of generality, of course, you can train your phone to learn all kinds of objects in the scene. And the challenge is, again, I want to highlight this, These detection algorithms have a learning stage, and they are computationally, in general, very expensive. So trying to do this all processing on this little mobile device and trying not to drive the user crazy by eating up their battery is a big, big challenge here. So here is the summary slide of our other research activities. So we took these phones and then we used them on a transportation application. So here the phone is pointing outwards through the windshield, and then we are detecting the tail lights of the vehicles that are in front of us, and then we are able to detect whether those vehicles are braking or giving right or left turn signals. And then at nighttime, it's a less challenging problem because we can always look for the red if we want to see whether the vehicle is braking or not. But we are able to do this both daytime and nighttime. And then we also have a system that can detect the status of the traffic lights. And then we were able to get about 97.5% accuracy in detecting the status of the light to help people with color vision deficiency. And then we also have an application in which we are able to detect multiple different planes in the scene, and then also 2 different motions. Thank you.